Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, empowering the world through engaging learning. I'm your host, Zach Memis, as we continue on with CompTIA Net Plus, Network Service Functions Part 2. We had a Part 1, make sure you see that too. And Wes Bryan is back again to complete this thought. Wes, good to see you. Thanks for joining us.
Hey, thanks for having me back, Zach. Yeah, these these network services that we'll be talking about over the next couple of episodes, they're really, really important. I mean, they really, form like the foundation for how we communicate, across a network. Remember that in the first part, we basically said, with DNS, domain name system, the service that is associated with it, it's responsible for taking names, mapping them to IP addresses. Remember, fully qualified domain names or FQDNs, and mapping them to our IP addresses. And it's a very, very important service because I tell you, I can't remember a single IP address. If you think about it, think about us humans, right? Today, a lot of us don't even know telephone numbers. We associate a name and maybe even a photo, of a friend that we've got in our contacts list, and we push that button and it maps it to a cell phone number and it contacts them, right? Well, different kind of number, different kind of name, but the theory's the same thing, right? It's easier for us to remember names than it is IP addresses, and DNS makes it so we can remember the names and not the IP addresses.
And we left you with a cliffhanger, and that was my question of naming. Like I'm Zach, that's Wes, but there's names, there's all these names we were talking about. What exactly are we talking about? Where do we find them? What are they for?
Well, I'll tell you what, let's go ahead and see if we can help you out on that one. Now, I got a little bit of a diagram here because we'll go back to that real quick and we'll talk about, they're what are known as records, all right? DNS records are actually stored on a DNS server, right? A little database, if you will. It's really just a text file, all right? And what you'll see here is that I've got an FQDN, all right, and it's mapped to an IP address. Now, the server, and in fact, let me go ahead, and for the sake of consistency, I noticed that this IP address is a little bit different, and it might confuse people because I'm going to use a different private IP address, all right? Now, it takes the name, maps it to the IP address. Well, that name to IP address, IPv4 specifically, is what's known as an A record. And the A record gets stored in what's known as a DNS zone file. Again, the zone file, database, it's really just a text file. It's a listing. Now, that is what's known as a DNS record. But it's only one example of a DNS record. We've got quite a few, all right? And we've got to talk about them, all right? So understand that these are the type of DNS records that we need to be aware of, all right? The very first one we have is an A record, all right? An A record, sometimes called an address record. All right, takes that host name, I'm just going to say host here, but host name, and maps it to an IP address. All right. Now, IPv4 isn't the only internet protocol we have, right? In other episodes, we talk about IPv4, and we also talk about IPv6, right? That 8-block hexadecimal, crazy long IP address. Well, those aren't A records, all right? The designers of DNS got a little crafty here, and they said since an IPv6 address has 4 times the numbers, right, or 4 times the bits, we'll call it a quad A record. Sometimes you see 4 A's. Sometimes they call it a quad A record. All right. A quad A record, A record if you want, I just call it quad A, takes that name and it maps it to an IPv6 address. All right. So we still have name mapped to IP address, but an A is an IPv4 and a quad A is an IPv6 address. Now, remember, DNS is not only responsible for mapping just names to IP addresses. The cool thing is it can also take services on your net. It is a service in and of itself, but it can take services that are on your network and so you know where to find those services and the IP address. So for instance, let's say in a Windows domain, I need to log on to the Windows domain, right, over the Kerberos protocol. Well, I got to find the domain controller. My computer has to know where's the domain controller so that I can send these credentials over to it and talk to it. So it talks to DNS. And it says, I need an LDAP server. Where do I find a service out there, a lightweight directory access protocol service? And DNS says, oh, you can find the domain controller over here at this IP address. My computer can finish the authentication process by communicating now with the domain controller by one of these records that we have here. And that's the third record in our list. That's an SRV record. Nope, that's not Stevie Ray Vaughan, as much as I would like it to be. That's how I remembered it on the exam, by the way. SRV, it's a service locator record. You might hear it called service record, but it's a service locator record, all right? You can do this for things like voice over IP phones, right? I need a session initiate, a SIP phone. Where do I find a device out here, or a server that's running session initiation protocol? Return the answer back to the client from the DNS server when it's asked. All right. Now notice we have another one here. We've got what's known as an MX record. This is called a mail exchanger record. All right. And what this does is essentially the mail exchanger record just takes a name, right? Or not a name. It's really the IP address of the mail server that's responsible for the domain. All right, so let's take google.com, all right? Google's got a mail server, all right? I need to know, where do I send the email to, all right? So I need to find the computer within that domain that's responsible for email. So I asked DNS, there's a mail server responsible in Google. Well, here's your MX record. You can go find the mail server at this IP address. Go talk to the mail server. All right, that's an MX record, mail exchanger record. Now, C names, they got a couple different names that they're called. They're called aliases. The term C name is just canonical name, but it's an alias. All right, and aliases or C names are interesting in the fact that they don't map to IP addresses. A little bit different. They map to a host record. All right, and let me show you a little bit more about that, right? Let's say srv01.demo.itpro.tv is my web server. Would you like to have to put that in a search engine every single time you want to come to itpro.tv? Well, we wouldn't want you to have to. That'd be a nightmare, right? So what I need some kind of alias that everybody recognizes, but still maps to this host that's running my web server. So what I do is I say, you know what, let me go ahead, and what I'm going to do is I'm going to create an alias for this server, and we're just going to call it www. So that when your web browser or your computer says, I need to find www.itpro.tv, where do I find it? Ask DNS. Same thing with Google, www.google.com. Same thing with www.microsoft.com. It says, okay, well, I'll look for www, and the domain name server, DNS server, if you will, looks at its database and says, oh, I see www. www is an alias or C name, and it maps to srv01.demo.itpro.tv, and that can be found at this IP address. Here's your answer. And now you as a human don't have to type in this long, crazy name. All you have to know is www. And I can type in www.google.com, www.facebook.com, right? And it makes it a lot easier. And that's essentially what an alias is, a C name, if you will, right? It's an alias or canonical name. Now, sometimes, and this is where it gets a little tricky, so up until this point, I said name to IP address, service to IP address. Sometimes applications, they're a little backwards. They're like, I got an IP address. I need a name. Uh-oh. Boy, you just threw a rock in the pond on that one here. Wait a second. You've been telling me names to IP addresses, and now you say, what are we going to do? We got an IP address, and we need a name? We got to reinvent the wheel and get another protocol, maybe DNS 2? No. That's what's known as a reverse lookup. All right. We talk about forward lookups. We talk about reverse lookups, and we'll get in a little bit more into that in a bit. But when I've got an IP address, or sometimes applications say, I've got an IP address, I need to know what its name is, it's going to talk to DNS, and if we can go back to my slide here, and it's going to look for what's known as a pointer record, PTR record, as they're called for short. PTR records, again, are pointer records that map IP address to host. So I want you to think of flipping it around. I've got an IP address, and I map it to a name. Now, one of the last ones that they want you to be aware of is what's known as a .txt record. And it sounds, for those of you coming over from A+, the extension that you had to remember, TXT, text document, that's essentially what a TXT file is. It's nothing more than a text document, and it holds text information in it. All right? And we use this for things like sender policy frameworks, SPF files, all right? And also domain keys identified mail, the DKIM files, all right? And these were clever ways that they would try to stop spoofing, all right? And what I mean by that is imagine I ask an answer. And Zach, you're going to have to help me out here, right? Go down to the land of make-believe, right? Zach is a DNS server. And I want to know, Zach, I need your email server. Where's your email server? Well, I need to know that who I'm asking is authoritative for that domain. All right, domain namespace. So it's interesting that domain keys, if you will, identified mail says, well, you know how you got the from field, right? When somebody gives you an email, well, how do I know that that email came from the right person? Well, if I implement things like private key encryption, public key cryptology, if you will, and we take a private key and we sign the response, create a digital signature, all right? And Zach gives me that response back, I can take, or even the email in this case, I can take the digital signature on that with Zach's public key and I could decrypt it. And if I can decrypt it, I can say, you know what? That certainly did come from Zach. I could tell that. So it's a way these TXT records, again, just associated with some kind of text in them. They're used for sender policy frameworks. Sometimes we use this to verify that the DNS server that you're asking the question, that you are the authoritative DNS server. You'll see this sometimes when you're setting up those hosted DNS services, where some of it's on-premise, some of it's in the cloud. Well, we need to know that you, as a cloud provider, I need to know that you are responsible for your DNS, that domain name, that you are the administrator. Because if not, people can do domain hijacking, right? I say, Zach, yeah, you can take care of this domain name space for me. You can trust me. Well, how does he know? How does he know that I'm not a hacker? Well, if I put a TXT record inside of my zone file, which as an administrator only I should have access to, and he tells me the exact information to put in the TXT file, and then he queries my DNS server for that information, if I truly am the administrator of that domain, then when he asks for that TXT record and he finds the information that he gave only me, he can verify that the response is coming from my DNS server, and because we set it up on the back end, that I am the administrator and I have the authority over the domain. Now, the domain keys get a little bit, domain keys are where digital signatures come in. That's where you can use public key cryptology to verify through a digital signature that Zach, let's say Zach sends me information from his email server, right? I can trust the email because I have to check that digital signature, that little electronic tamper-resistant watermark, if you will. All right, so great things to understand. Now, one of the last things that I want to talk about is what's known as a forward and reverse lookup zone. All right, when we talk about forward and reverse lookup zones, all right, notice that if we can go back to my slide here, notice that I said that we have host addresses to IPv4 addresses, host names to IPv6 addresses, services to IP, mail exchanger, all right, a record is again, who is the responsible email server for this domain namespace and what's its IP address? And then we got to the pointer record and I said it's an IP to host, and I said that's a reverse lookup. What does that mean? Well, you have what are known as zones inside of your DNS databases, two zone types. You have what are known as forward lookup zones, and you have what's known as reverse lookup zones. Let's talk about forward lookup zone. Forward lookup zone, name to IP address. Now let's make it easy. Let's take all the technical jargon, just throw all that, the acronyms away. All right? Forward lookup, name, service, alias, mail exchanger to an IP address. When the IP address is the last part, that's what you're trying to map to, it's a forward lookup. We switch it around. The reason I said we reverse the order, now we're taking an IP address and we're mapping it to a name. Your PTR records are the only ones that sit in the reverse lookup zone. All these other record types sit in that forward lookup zone file. The reverse lookup zones have their own file as well. And guess what? The only record there is the PTR record, or the pointer record. And that maps the IP address to the name. So know those zone types.
So, Wes, can we see a little bit more about how all this works?
Absolutely. You know, let's go ahead and let's do that. All right, let me go ahead and dive into my Windows server here. And it looks like it timed out on me. So if I can remember my super secret password here, we'll go ahead and log in. All right, so I'm on a Windows server here. All right, and if I go up to Tools, right, and we scroll down, you're going to see that we've got a console here. And you can see that DNS is in the name. All right, and this is our DNS manager. Now, when we look at our DNS manager, one of the things that you're going to notice is here's our server, and we got forward lookup zones, and we got reverse lookup zones. Now, by default, you don't have anything in the reverse lookup zone. You have to create the reverse lookup zone. Don't worry about that for the exam, but we're trying to show you, like Zach said, a little bit of hands-on here. All right, but I do have, if I expand out, I have what's known as a forward lookup zone. Remember, we've been using demo.itpro.tv. There's my forward lookup zone. And if I select my forward lookup zone, I'm going to notice that we have some records here. All right. Notice I have an A record, and it maps to this IP address, right? So name client01. In fact, let's go ahead and let's look at the properties of this record. All right. This is why I said host to IP address. Again, you'll look at some of the verbiage will differ. It's a host name, host. So here's the host name, right, or computer name, if you will, and I can show you that here if I look, and its IP address. Let me go ahead and just finish my train of thought here before I jump ship here. Notice that I have an IP address. So it takes its name, maps it to an IP address, all right? And its fully qualified domain name becomes a combination of the host name and then the domain name, all right? And that's important to understand. Now, we can also jump over here to my Windows 10 machine. We can get logged in here real quick. And I can show you that if I right-click on the Windows charm and I choose System, and let's say I just go ahead and get some system info here, I can see, looks like a little screen refresh there, that it's also a computer name. All right, so host name, don't let that confuse you. The Windows World host name and a computer name are the same thing. And then I can also see the domain that I'm attached to. So again, computer name or host name plus the domain name equal, and this says full computer name. Again, just more verbiage, that's your FQDN. And you can see that that record resides here in the forward lookup zone in this database. All right, now we have other records here too. All right. But if I wanted to, you can see I can right-click and I can create additional records. Right? Here's my Exchanger record. If I needed to map to an email server with that's responsible for this domain namespace, I could create one here. I could also create the quad A, which is the IPv6 address if I wanted, or I could do a canonical name, an alias. All right. So again, let's do a little make-believe here, right? Win81A. Let's just say that that's my web server. I don't want anybody to have to type or try to remember Win81A. So what I can do here is I can right-click and I said, let's make an alias. And I want you to notice something about the canonical name. All right, when I type www, that instantly becomes a fully qualified domain name. And notice the trailing dot there. Zach, you see that?
I certainly do.
That's the root.
That's your root.
Right? So it's there. The DNS server is using it. Your web browsers are using it. We don't use it as humans, right? But it isn't implied. All right. Notice it's not asking for an IP address. Remember I told you the aliases don't map to IP addresses. They map to FQDNs or the hosts that they're associated with, right? So if I browse, I could browse the DNS database and I could look up in the forward lookup zone and I could find the host that I want. In this case, it's Win81, right? Or if I wanted to, and I was a glutton for punishment, I was going to check my typing skills, I could do a Win81A dot demo, like I said, challenging my typing abilities, dot, right? And I can't remember if you need to. You don't need to, I don't think so, but I think you can put in the implied dot as well. So what's going to happen now is when somebody goes to try to resolve www, the DNS database is going to look and it's going to say www. Yeah, I see that. I've got an FQDN called www.demo.itpro.tv, and it maps to this host, this fully qualified domain name, and then it goes a step farther and it says, okay, so let me look at this fully qualified domain name of that host that we just talked about, and here's its IP address, and it returns that answer to the local computer. Now, let's jump over to our Windows 10 machine here, and let's bring up the properties of the network adapter by right-clicking on the little monitor icon down, my head's kind of covering it up, but right-clicking on the little monitor icon and choosing Open Network and Sharing Center. We'll go ahead and choose Change Adapter Settings, select Ethernet 01, right-click on it, and we're going to choose Status. From the Status dialog box, we're going to go ahead and choose Details. All right, now remember what I said, that your TCP/IP properties of your network adapter will dictate which of these, what DNS server you use. Now, I have put in the DNS server, basically the IP address of the DNS server that we were just looking at. So when I try to do name resolution, it should look to that DNS server and ask a question. Let's see if it does. All right. So let's go ahead and let's use a name resolution command, and we will test this out. We're going to go ahead and we'll open PowerShell. You can also do the command prompt if you would like, and let's go ahead and clear the screen off, give ourselves a little bit more real estate here. And we're going to type NSLOOKUP, which is for short for name server lookup. If you're in the Unix world, Linux world, and even on Mac, you can use what's known as domain internet groper. All right, dig, the dig command. That's what they use to test name resolution out. NSLOOKUP is in those systems too, but it's kind of outdated. Microsoft keeps it around in their systems for DNS name resolution testing. So we're going to go ahead, and what we're going to do, remember we had that record, that canonical record? I'm going to look for it. I'm going to do NSLOOKUP space, and then the fully qualified domain name, and I'm going to type www.demo, maybe, .itpro.tv, and we're going to see if it'll resolve the name. All right, now we're getting a little timeout here, and that's fine. But what we should see is that it asks the DNS server, all right, where's www.itpro.tv or www.demo.itpro.tv? And the DNS server just looked and said, yeah, I know where www is. And it looked and it said, oh, it's this host. And then it looks at that host, it looks at the FQDN, and then it says, let me see that FQDN and what the IP address is that it mapped to, and it returns me the IP address. Right? So if I switch back over, remember we said, here's the host that it was looking for and its IP address. And that's what it did. It said, yeah, I see www. Let me go ahead. Let me look at the properties of www. I see that maps to this fully qualified domain name, and that fully qualified domain name is an alias for this host or this FQDN. Now that I know that, let me go ahead and I'll look at the properties of that FQDN. And yes, I see its name or its FQDN is mapped to this IP address, and it returns that answer, essentially, back to my computer. If I get that back in the screen there. So that's your name resolution, right? Not really too difficult. It is important to understand that DNS is really one of the most important services. Now, I'll also let you know, too, that you can use a couple other things, a couple of other, I should say, commands, too. Like, for instance, Internet Protocol Configuration, ipconfig, we can use that as well. And ipconfig, it really does a lot of things to the properties, the IP properties of your network adapter. All right, one of the things it can do is display that resolver cache. So if I did an ipconfig space / display DNS. Well, didn't we just ask for a DC, a domain name? Remember I told you my computer has to find the domain controller? I don't know where the domain controller is, right? So DNS says, yeah, here's your domain name controller. You can find it right here, and you can find it at this IP address. All right. Now, it's interesting that it didn't cache the www, but let's go ahead. I tell you what. Oh, and you know what? If I would have tried to browse www via the web browser, it would have cached this response. When you use NSLOOKUP to test whether name resolution is happening, you're not looking here. All right. You're not looking at the local resolver cache. All right. So just understand, and I can actually, if I wanted to, I could switch over to my, remember I told you DNS servers even have a local resolver cache? Let's go ahead and let me adjust this font size a little bit. That is definitely really small here, a little hard to see there. All right, and let's go ahead again, let's give some space here. And if I do an IP config space / display DNS, I've got a few here. All right. And I can see that there are some answers here inside as well. Notice your CNAME record here is likewise. All right. Now there's also a TTL. I'm just going to mention the TTL here too. The TTL is time to live. All right. And you might not want these records staying valid forever. Because notice my local resolver cache. My local resolver cache, remember I said if I've got the answer locally, then I'm never going to ask a DNS server the question. It's important to understand that I also, again, we have services. If we look, we can actually see the DNS client service here. And we'll go ahead and filter this down by name. There's my DNS client. All right. And that DNS client service has to run, all right, for you to cache, right? Notice it says that if you turn this off, the results of DNS name queries will not be cached and the computer's name will not be registered. Registering DNS is when my computer says to the DNS server, hey, I'm here, I'm a part of your domain, and guess what happens? Your computer dynamically registers that IP address, all right? Well, I want you to go back to the cache for a second as it relates to TTL, all right? What happens if an IP address changes, all right? Well, if an IP address of a host changes and it doesn't map what you have in the cache, remember, you're not going to ask the DNS server anything. You've got the answer, whether it's right or wrong. So we put TTLs on these records that say, okay, use that record for this amount of time. After this amount of time, I want you to purge it, flush it right out of the cache like it doesn't exist anymore, and then ask the DNS server a question again. Some, and you'll learn this as you go on into more advanced training, some records you want to cache for a very short time. You don't want them cached too long, right? Other ones where you know the IP address isn't going to change, sure, you can leave it 24 hours. It doesn't matter. But there are certain records that you will want to change, and you want them to purge out of the cache and not stay there forever. Because let's face it, if you're one of those ones, I'm raising my hand here, that never turns your computer off, you might have a DNS record that's been in the cache of your RAM now for a month, and things do change, right? So you do have to understand that things do change. Now, I will tell you one last thing about record creation. I know we're running out of time in this episode that I do want to mention, is that records can be static or they can be dynamic, all right? Here, when we talk about dynamic records here in the Windows world or the Microsoft land, you could typically tell the difference, right? Static, kind of obvious on that one, right? And what that means is it's been manually created. Now, I didn't create one for the DC. Okay, because this domain name system is integrated into Active Directory, a couple of these were created automatically before I did anything, all right? But if I say, you know what, I got a host out there, right, and it's going to be client 03, all right, and its IP address is going to be 192.168.1. Now let's do this in tens. I add host. All right, notice that I have created this record myself, all right? Now you can, and that's a manual creation, all right? Now you can also see the TTLs. Now by default, if I right click on this and I choose properties, you don't see the time to live at all. That's actually an advanced feature. So if I go up there, if you ever working with our practice labs, if you're following all along at home, right? You go up to your DNS Manager console and you choose Advanced. You'll get a lot of extra records there that you can learn on in some of the courses that we have that are more advanced. But if I right-click and I choose Properties, notice what I have here, a TTL. All right. And the TTL, you can also do a record stamp that says delete this record when it becomes stale. Again, if the record no longer, it's gone past its TTL, it becomes a stale record, and it will basically be flushed out of the cache. All right. Now, that was a stat or a manual creation. All right. Let me go ahead real quick and let me delete Client 02. This computer that we've been dealing with is Client 02. And I'm going to go ahead and I'm going to delete that record. And we're going to switch back over to our Windows 10 machine here, and I'm going to bring up the properties again of its network adapter. And we're going to look at, in this case, Internet Protocol version 4, choose properties, and notice that I have a static IP address, and I have statically mapped, if you will, a DNS server. All right. I can change this to DNS or DHCP, and depending on how I have my domain set up, when I obtain a DHCP assigned address, I can also dynamically tell DNS, hey, DNS, I just got a brand new IP address. I need you to update your records. And it reaches out to that DNS server, provided you have the authority to do that. You have to be a domain member. There are a couple of stipulations on that. Not just anybody can do that. Computer has to be joined to the domain. It can say, new IP address from the DHCP server. All right, records don't match, or let's go ahead and update it. And it dynamically either registers it for the first time or it updates to match and reflect the new DHCP address. Very cool things. Mm-hmm. Which leads us into our next service, DHCP, which also runs us out of time.
Aha, another cliffhanger. Network Service Functions Part 2. There will be a Network Service Functions Part 3 where we look at DHCP. So you don't want to miss that. And you don't want to miss anything in the CompTIA Net Plus series. Wes is doing a wonderful job. He always does. And in fact, check out the rest of the course library. There's so many videos, and they're all there to do one thing, help you go further. And tell everybody you know about IT Pro TV. They'll be very glad you did. Thanks for watching. I'm Zach Memis.
And I'm Wes Bryan.
And we will see you soon.
Thank you for watching IT Pro TV.